Okay, so welcome to the Dapr Day 2024 virtual conference. The subject of today will be Dapr and KubeMQ. And so we will do the presentation with Lior.
Hello, hello everyone. My name is Gilles. Nabat. I'm founder and CTO of KubeMQ. You can find me and connect me in GitHub and also in with email at lior.nabat and at kubemq.io. Very happy to be here.
So me, Gilles Flisch, I'm leading the .NET team at Elia Group. You can join me at gilles.flisch@elia.be. I'm also owner of a framework available open source, available on GitHub, and also working on a guidance tool which is available on the Visual Studio Marketplace. You can reach me to the email address info@refogu.net and at gfish for you on Twitter. So the first thing that we would like to say is that we did already a presentation on the Dapr Community Call 79, presenting Dapr and KubeMQ and all the work that was done by Lior. So please check this first. It's also valuable information. And on the agenda today, the purpose is to really show how to work, how to use Dapr and KubeMQ from a dev machine to a Kubernetes environment. Okay, so it will be with .NET 8 and even Aspire 8. We will spend some times about setuping everything, but also how to build a microservices application and which are the best practice regarding Dapr and the configuration to use it correctly from the dev to the production environment.
Okay, what is KubeMQ? KubeMQ is an enterprise-grade message broker and message queue. It's very scalable, high availability, and secure, meant to be run on native Kubernetes cluster. KubeMQ has 4 components in the ecosystem. One of them is the main one is a KubeMQ cluster. It's a very small, fast, and lightweight cluster of messaging broker. And we have 3 families of components. One of them is the KubeMQ targets, that is open source, that able to connect KubeMQ cluster to different sources like databases, cache, many other what we call third-party targets. The second one is sources, meaning that it's a component to ingest data into KubeMQ. And the third one is what we call KubeMQ bridges that able us to connect between KubeMQ cluster in order to provide some hierarchy and able to build a complex architecture of KubeMQ cluster together. What I'm going to show you now is how to set up very quickly KubeMQ in your desktop. We're going to use the Docker version of KubeMQ. A binary will be soon, a direct binary will be soon be available. And now what I'm going to do, I'm going to show you the whole flow of how to run it. So in order to get a KubeMQ key, in order to run KubeMQ locally or in your cluster, you can go to kubemq.io and click on the try free button. When you will click it, you will be redirected to the account page. Here you have 3 options to sign up. So I'm going to use the Gmail option. I'm going to click on it. And after 2-3 seconds, I will be able to register. And then we have the options to how to install KubeMQ. I'm going to use the option with Docker. I'm going to click on the run Docker and just pass it to my terminal, run it, and that's it. I'm going to go back to my web, and I can click on the dashboard, and here I'm getting the KubeMQ dashboard in a couple seconds.
Okay, fine. So I will now present. So I will share my screen to show you what personally I'm doing. Also is so I'm back to the presentation. You see that me personally I'm mapping a volume, meaning that if I show on my local on dev environment, I click on the dashboard of KubeMQ, we can see that I have already some topics that exist. So I will just now show you that how easily, and this is something that I like, because when we develop, sometimes we want to have something really clean to understand the different messages that are sent. So what I just do by having this capability to map to a local storage, so I just stop here, I go to the folder where I've mapped. There is a store which is created. I just delete so if you look at the store, you will see that there is somewhere binaries to store the information from the messages that are used by or sent to via KubeMQ. So I will just delete it. And now when I restart my Docker image and I click on the KubeMQ dashboard, see that I have a fresh image with no topics, no channel, nothing is there. And so I can start with a fresh image. I can compare when I'm playing with the application. We will go back to the dashboard in the next part of the presentation. So now, concerning the cell-based architecture at Elia, we are analyzing the business needs, and we are decomposing this in 3 levels. The lowest level is the level that we will use to start to build the cell, which is a set of microservices that will just implement the business need. We have an API gateway and a messaging platform, which is used by here KubeMQ to exchange the messages between the different cells in the cell and outside of the cell. The guidance is supporting this and will create everything regarding the gateways, the services, and adding Dapr to deal with the messaging platform and the cache. Regarding the cell-based architecture, when we implement this in the code, what I like is that the developer has the same configuration that he will have to build when he will deploy in a production environment. So it means that locally on the development, all the components that we have to use for all the services that exist in a cell, I put this also in a one folder, and the developer has to deal with the scope and define this correctly to select which is the component that will be used for a specific services. Exactly like when we deploy on Kubernetes, we deploy in a namespace all the components, and we have to play with the scope to say this component is used by these services and not by the other one. So now we will see this in the solution that I have. So we can see we have a structure with a backend and front end, but we will look at the backend part. And so we have different services: contract, core, mail. And what we can see is that we have a Dapr folder. And the Dapr folder is where we will see the different configuration that will
will be used when we develop in development, or here in this case the staging one. What we see is that the same components are defined for the development and the staging. And if I take here the store one, we see that we use the scope to define which is the service that will be using this one. And so the developer has exactly the same constraint regarding Dapr with the defining the good scope when he will run. And so after, it's just a copy paste that we have to do and to give only the configuration regarding the address or the password.
For the Dapr component with KubeMQ, we adapt the PubSub. For example, in this example, we adapt the PubSub pattern with Dapr. And what you need to set up is simple. The address of your KubeMQ cluster or instance. In this case, we are running on localhost. Then we have two what we call PubSub event type. One we call event, and the second what we call event store. The difference between them: events are very fast PubSub that in memory, and store is a PubSub with persistence. Means that you later on be able to retrieve message all one, start from beginning, and any kind of replay mechanism with your channel. Grouping a group is the ability to group couple clients together in order to be able to do some, for example, load balancing between services. A client ID is a unique ID for the service in order to identify to KubeMQ service, say KubeMQ server, which one is the client is connected.
Okay, so Lior, if I'm on a service and I just publish a message to a topic, in this case, the group and the client ID is not something that I need to configure on the component level because it's not used, in fact.
Yes, but if you want to keep the name of the server who sent you in order to see in your dashboard the details, you will need to set the client ID. The group you don't need. The group is only on the receiver side.
Okay, good. So and so if you have your services deployed in the Kubernetes environment that you say replicas is set to 3, for example, and if you want to just receive the message that it was published by one of the instance, you'd have to define a group. Otherwise, you will receive the message 3 times. So it's really important to have this concept in mind. It depends on what you want to do, in fact. When I generate the code via the guidance, is that the components directory is linked to the development folder. And just I remember, because we define all the services that we will start, I will show you this in Aspire, are linked to the same folder where all the components are defined. It means that immediately the developer is in front of the same way Dapr is configuring when you deploy in Kubernetes, meaning that you have on your namespace a lot of components that are declared, and just the scope is used to trigger, to filter what will be used for these specific services or not. And so when they are developing and they do a mistake, they will see this immediately, and they will correctly, they will be able to correctly configure the staging or development environment. So now I will switch to the solution, and I will go to on the app settings, I think here I've already claimed this, so because I'm on Aspire, so there is no Dapr Sidekick. So you see before, I was using Dapr Sidekick locally on the development machine. We are still using it. And on this project where I'm able to run this with .NET Aspire to check and validate everything, in this case, I comment this part, so Sidekick will not be used. And if I look at the Aspire solution here on the program, I can see that for each service that exists, okay, I have a Dapr Sidekick. So I'm using currently the preview 2. The preview 3 theoretically is for this month, February. But at the moment we are doing the record of this presentation, I'm only on preview 2. And you see that we define the resource path, and the resource path is just to mention the Dapr development environment and all the configuration that we use. And this is something that I use for each services. And those services will be deployed at the end in Kubernetes in a namespace. So really important. I will do a demo and showing the dashboard, and we will see this. So it's not the moment for the moment to show that. I will again continue the presentation. Now, when we go in production, we have not yet for all the application Dapr and in Kubernetes. So we are not fully migrating in Kubernetes. So for the application that are not yet able to be deployed on the Kubernetes environment, it's more because we don't have yet a Kubernetes on-prem, and for critical application, we don't do this in the cloud for the moment. So in this case, we are still running Dapr via Sidekick as an NT services. So we use the Sidekick functionality, we activate this via the settings. But when we deploy in Kubernetes, in this case, we just annotate the YAML file, the deployment manifest. We mention the app ID, and we remove the section with the Dapr Sidekick. And so we are able really to switch from so locally, it will be on Aspire 8. In production, it will be or as an NT service or in Kubernetes. And we are really flexible, and we can play this easily with this. And this is what I like in architecture, is the capability to really switch and have a lot of flexibility. So now we will see the KubeMQ dashboard and all the possibilities. And for this, I will just start by running the application with the Aspire and show this in live. So I will run the application. So I start this. And Aspire will start everything for me. So he will launch all the different services. He will launch the Aspire dashboard. And we can see that Aspire will start the Dapr sidecar side by side with the different services. Then it will also give me the access to the YAP, which is just a component. And when I launch this, the YAP will be launched. I'm able to connect to my Swagger page. I can go to the different services that exist, and I can, for example, query the list of components. That's more or less what it's done. We will see the part regarding the tracing. So we have now everything which is done nicely, and I can see also, I will show you this, the logs of the Dapr. I can see that the KubeMQ component is started correctly. So we have the secret store, but we have also here the pubsub KubeMQ, and we can see this. So we have an environment which is up and running. Now I will go to the demo HTTP. So I will launch the dashboard of KubeMQ. And know that I've started the application, even if there is no message, I have already the services who have who are listening to the different topic that I create for this application, and I will we will have a look on what is going through the user. So when we create a user and so on, there is a mechanism where a message is sent. It will be create a message to say, okay, you are registered. And so Lior, there is here two concepts, which is subscribing and watching. Can you explain which is the difference between the subscribe and watch?
Yes, the subscribe is a simulation of real client subscribe to the message, like to the channel. So he actually will get the messages, and watch is like a monitoring, means that like an eyes what's going on the channel, and is not looking and actually accepting the client. So it's like mainly for debugging and or development mode that you will be able to watch on top of the channel. By the way, it's very useful in other messaging pattern like command inquiries that you can see who is sending a request, who is responding, and this is the same way how you can really watch on the channel, see what is the traffic running in this channel.
Okay, so I will subscribe to this channel, meaning that now when I will publish a message, I will be able to see, and we will see the content, what is in this message. And I'm using the cloud event, so I'm using Dapr with cloud event, and so I will see what is happening. So now I will show this in the application again. So when I have subscribed to the user, so I will create a company. So there is a message which is sent, but I will show you this with the user. And now I will create a user. So when I create a user, a message is sent to via Dapr and KubeMQ to the mail services. A mail is sent, so you can see here the mail which is sent. And I go to the Dapr, the KubeMQ dashboard, sorry. And when I click, because I subscribe, I can see the message and the content. So here you see the data. So it's a cloud event message. So meaning that we have the cloud event information. So and the data is my message really, and we can see the trace and the trace ID which is used to for the open telemetry. I will show you this in Aspire. And so based on, we use also the type to after listen, and based on the type that is used, the message will be routed to the services to be handled by the mail one. Okay, I will show you this in the project because it's really interesting probably to show this. So thanks to that, I can see what is happening on the wire. And when I subscribe, which is also interesting, is that I can take a copy of this message and I can republish it. Okay, so I can just take it. I will resend this to. I will send it and know that I have sent it, but the mail is resent because the mail is receiving the message again. And so this is really handy when you are debugging your application and you have a full process and you need just to test a component. You just publish the message again and again, and so you can debug your services, and it's really really interesting, this feature, and easy for a developer to use this via the dashboard of KubeMQ. So now, if I go back to the the project, what I do also is that for at the level of the project, I have for each services that exist a Dapr controller, and I will not use this one, which is not really interesting, but I will use the mail one, for example. And so the Dapr controller is something which is with a specific group name that I exclude from the Swagger page because it's only something that will be used by Dapr. So I don't want to be able to see this in the Swagger page. And for each event that is created, I have a post with the root. And if I look at the Dapr component for the mail, there is a subscriptions definition, and here you can see for the type of message each route that will be used to reach the services, and this is how the glue is done. So we have seen the message created, the cloud event type is also sent. KubeMQ is transporting this. I can see this in the dashboard, and this is mapped to the good endpoint via the subscription. Regarding a little open telemetry concept, is not really the open telemetry one, but here the KubeMQ has the concept of also where you can see all the clients that were connected and exchanging messages via a specific channel, and so it's a nice view. Sorry, it's a nice view because you can already see and have information about who is sending, who is receiving, who is sending and receiving. Okay, so a nice feature that helps to understand. I can see now really the normal message I'm using, not republishing multiple times via the dashboard the message. I can see the gateway code with all the concepts which are inside regarding the security, the contract which is called to create the user, the message which is sent via Dapr and the PubSub mechanism, and I can really see the trace and all the detail about this message via thanks to the open telemetry. Lior will explain the KCC tool and what is it exactly.
KCC, just run it, and then automatically it will open a new web page. I can see that I have the dashboard. It's currently clean. There is no KubeMQ. I have running K3D as a local client, a local Kubernetes cluster. What I'm going to do now, I'm just going to click, put my license key to add cluster, and that's it. We're going to wait about 10 to 12 seconds. He will bring up all the necessary components. In Kubernetes, we are using operator in order to load all the KubeMQ components, as we have reach, target, sources, and then in 10 seconds, we can see that it's up and running. If we want to look on the dashboard, you can click here, and this is the dashboard of the cluster that you have. You can see we have currently 2 nodes. The nodes are going up as we speak. You see the third one going up, and then we can, from here, we can continue If we want to see more, we can see logs, we can see services, endpoint. We can do port forwarding if we want to have a local exposure to the cluster. So we can set here, and then automatically all the traffic for port 50,000 on gRPC will be forward. Here we can have more all the settings, images, authorization, TLS, routing, health, many things that to run. Out of the box, KubeMQ is running almost without any configuration, and that's it.
So thanks, Lior. I think it's really, really interesting and how easy it is to finally deploy KubeMQ in the production environment. The last slide, which is the Q&A, question and answer.